Imagine watching a hurricane pass your island without ever making landfall, and then discovering that roads have disappeared, bridges are damaged, homes have been swept from their foundations, and more than 100,000 customers have lost power. That is what happened in Hawaii when Lala moved past the islands in August 2026. Stay until the end, because the most dangerous part was not simply the wind. It was the enormous amount of water delivered to terrain that could not absorb it fast enough. Lala approached Hawaii as a tropical storm and strengthened into a Category 1 hurricane before reaching the islands. Forecasts warned of a rare and dangerous event. A direct hurricane landfall would have been extraordinary because the island had not experienced one since 1871. But the final track was different. Lala passed west of the islands and weakened back to tropical storm strength. That weakening did not make the situation harmless. On the Big Island, the northeast coast recorded extraordinary rainfall. At Laupaho'o, the measured storm total reached 43.54 inches, or about 1.1 meters. That is more than a year's worth of rain in some places, delivered during one storm. Parts of the windward Big Island received several feet of rain. Then the terrain became part of the disaster. The Big Island is dominated by steep volcanic slopes. When enormous amounts of tropical moisture fall onto those slopes in a short period, water rapidly moves downhill. Rivers rise, roads flood, saturated ground becomes unstable. Landslides can develop with little warning. A storm does not need to destroy a building directly if it can cut off the road leading to that building. That is exactly why Lala became so disruptive. Floodwater damaged transportation routes and bridges, while debris and fallen trees made movement even harder. Pahala, a community in the southern part of the island, was temporarily isolated, raising serious concerns because the area has a major hospital. Authorities also reported that more than 100 homes were damaged, with some homes swept from their foundations by floodwater. And then there was the power grid. At one point, more than 180,000 utility customers across Hawaii were without electricity. On Oahu alone, outages had reached more than 220,000 before falling as crews began restoring service. Trees and power lines came down, while flooded roads made repairs more difficult. The rainfall threatening homes also slowed emergency response. The wind added another layer of danger. Although Lala had weakened by the time it moved west of Hawaii, strong tropical storm force winds continued across the islands. At lower elevations, winds reached tropical storm strength, with gusts up to about 60 miles per hour reported. At the summit of Mauna Kea, one of the highest points in the Pacific, a gust of 140 miles per hour was recorded. A storm can produce very different conditions at sea level and at high elevation because terrain changes how air flows. There was also a dangerous coastal threat. Large waves, strong currents, and rough surf continued even after the strongest winds began moving away. The storm had become a combination of flooding, landslides, infrastructure damage, power failures, and dangerous ocean conditions. And there is one detail about Lala that makes this event especially important. The storm did not need to make a direct landfall to cause major damage. Its center remained offshore, but its outer bands pushed enormous amounts of moisture across the islands. Hawaii's mountains forced that moist air upward, helping produce intense rainfall over the windward slopes. This is a classic example of how tropical cyclones interact with local geography. The storm supplies the moisture and energy. The terrain determines where much of that water comes down. By Monday, Lala was moving west, and the immediate wind threat had decreased, but saturated ground could still produce landslides, while dangerous surf and rip currents remained along exposed coasts. So was Lala simply an unusually strong hurricane? Not exactly. The real story is more complicated. A storm can weaken in wind speed and still remain extremely dangerous because rainfall, terrain, flooding, and infrastructure failures do not instantly disappear when a hurricane becomes a tropical storm. But scientists and emergency officials were watching something else closely as well. Because if Lala's most destructive feature was not its category, but the way its moisture interacted with Hawaii's terrain, then the bigger question is this: What happens when a similar storm follows a different track, arrives with even more moisture, or strikes an island before weakening? That is where the story of Lala becomes much more important than one storm. The most important lesson from Lala is now becoming clear. Hawaii did not need a direct hurricane landfall to suffer major destruction, and history shows that this is not a one-time anomaly. In 2018, Hurricane Lane approached Hawaii as a powerful major hurricane. It also failed to make landfall. Yet Lane produced record-breaking rainfall. One National Oceanic and Atmospheric Administration station on the Big Island recorded 47.59 inches of rain in just 4 days. Another measurement used by the National Hurricane Center reached 58 inches for the storm. The result was extreme flooding, even though the Hurricane Center stayed offshore. That comparison matters because Lala followed a similar physical pattern, although the storms were very different in strength. Lala's heaviest rainfall was recorded at Laupahoehoe on the northeast coast of the Big Island. The total reached 43.54 inches, about 1.1 meters. That amount did not fall evenly across the island. Hawaii's volcanic mountains forced moist tropical air upward, helping concentrate rainfall on windward slopes. Once the ground became saturated, additional water had fewer places to go. This is where a tropical storm becomes an infrastructure disaster. A road can survive strong winds but fail when floodwater removes the soil beneath it. A bridge can remain standing through a storm and then become unusable when debris blocks its approaches. Power lines can be repaired, but crews cannot safely reach them while roads are underwater. And homes can survive wind damage, but be swept away when fast-moving floodwater changes the landscape around them. That is what made Lala so disruptive. Authorities reported that around 100 homes on the Big Island were swept from their foundations. Trees and power lines fell. Bridges and roads were damaged. Pahala was temporarily isolated, creating an especially serious problem because the community has a hospital. At one point, more than 180,000 utility customers across Hawaii were without electricity. Yet the storm's strongest winds were not the whole story. At lower elevations, tropical storm force winds reached roughly 30 to 40 miles per hour, with gusts up to about 60 miles per hour. On the summit of Mauna Kea, however, a gust reached 140 miles per hour. The enormous difference demonstrates how Hawaii's elevation and terrain can transform conditions across very short distances. By Monday, August 17th, Lala had moved west of the islands and the immediate wind threat had decreased. The National Hurricane Center said there were no coastal watches or warnings in effect for Hawaii, but the danger did not disappear instantly. Saturated slopes could still produce landslides, while dangerous surf and rip currents remained along exposed coastlines. The latest forecast also contained an important detail. Lala was expected to continue westward over the open ocean and could regain hurricane strength by Wednesday, far from Hawaii. That does not mean another disaster was expected for the islands. It means the storm's intensity could change again as environmental conditions changed over the Pacific. So what should we learn from Lala? First, hurricane category alone does not describe the full danger. A lower category storm can still produce catastrophic rainfall if its track, moisture supply, speed, and interaction with terrain line up in the wrong way. Second, Hawaii's geography is a force multiplier. The islands rise sharply from the Pacific, so tropical moisture can be lifted rapidly into heavy rain. Valleys, steep slopes, rivers, roads, and coastal communities then determine how that water affects people. And third, Lala is a reminder that the most dangerous moment is not always when the storm's winds are strongest. Sometimes the greatest threat arrives afterward, when the rain has already fallen and the ground is saturated. Lane showed this in 2018. Lala showed it again in 2026. But there is an important difference. Lala's damage came without the center crossing the Big Island. A future storm with a different track could interact with Hawaii in a very different way. That does not mean such a storm is coming. It means emergency planners have to prepare for more than one scenario. For now, Lala is moving away from Hawaii. Cleanup is underway, and officials are assessing the damage. The immediate danger has eased, but the scientific lesson remains. A storm does not have to hit you directly to change your world. And in Hawaii, the mountains can turn the moisture of a distant tropical cyclone into a flood disaster on the ground. This story is still being monitored, and as new official information becomes available, we will continue following what happens next. If you want clear, fact-checked explanations of major storms, earthquakes, extreme weather, and other natural events, subscribe